Okay, let's talk about whether light is particle or wave. I mean, today's one of the, I mean, how should I phrase it? One of the most talked topic is that whether light is particle or wave. I mean, we see both characteristics um, on the light photon. In the case of you, for the wave nature, we see the experiment like Young's double slit experiment, and for the particle-like behavior shows up in the experiment like um, the photoelectric effect, which is why the Einsteins also got the Nobel Prize. So it's a bit of counterintuitive to think that it behaves sometimes like wave particle and sometimes like wave. Sorry, it behaves sometimes like wave and sometimes like a particle. But why is it? I mean, it's why? I mean, why does it behaves like that? I mean, mostly if you uh, look a close look, you may see that when light is traveling, I mean, for example, to slit, it happens like a wave. I mean, it executes like a wave, and but when it's do something like collision or with another heavy particle, it just behaves like particle. So now, I mean, the question comes that why is it? Or are we just missing something? I think the problem is our thinking. Our thinking is biased by our experience. For example, how do we get the particle characteristics? Uh, we see, if you think deeply, you will find out that the particle characteristics is our intuitive notion. I mean, we see our daily example how a ball works, how a solid object works. From that thing, we kind of draw our imagination that this is how particle acts, little ball colliding each other and going like like the real object we see around. And also the wave, that characteristics we got find out by, I think, watching the river and rope. Yeah, uh, yeah, it's a kind of pattern. So that also our intuitive notion for us, both particle characteristics and the wave characteristics. Both are our both we learn how these characteristics are from the real world experience. Now, I'm going to pause you there for a moment um, that uh, think about for a moment. Our particle and wave-like behavior, what we see and experience in that macro scale, is also a construction of that quantum scale thing. So it doesn't necessarily should be that what we see in the macro scale, like the ball and the wave, should also be in the quantum scale. Yeah, surely quantum skills behavior manages to immerse that particle, um, aka ball, and the wave-like, aka wave in the ocean, like behavior that just emerges from those um, quantum property. But that doesn't necessarily mean that what is an emergent property also should be in the quantum scale. Quantum scale constructs are macro scale, so that doesn't necessarily mean that our macro scale behavior should be followed by there. But what I think is that um, it's a wrong notion. I mean, photon light has its own characteristics. It's maybe exotic, doesn't match our intuition, but we see its particle-like behavior sometime and wave-like behavior sometime, but it exhibits its own behavior. Maybe we need a more better theory will which will determine both property at the same time. Maybe just that's how the photon works. And we can also think this thing into the quantum mechanics and the gravity theory of Einstein too. They don't match yet. I mean, we try to we by assumption take that in fundamental scale the universe is simple. It's not complex than the emergent one. But we should be skeptical on that too. Maybe what if um, it's on the fundamental scale it's complex too again. And also um, what is simple and what is complex is also maybe a matter of perspective. I mean, we think particle like behavior is simple because we are experienced with it, and that could be a key too. I mean, what is simple, what is complex is also gained by our experience, or gained by our experience, or evolutionary intuition, or whatever you say it. It's just experience, either through evolution or through personal experience. So our experience took us a lot further. I mean, our imagination works, but on the quantum scale, if we go as much as deeper, we see that our intuition just, I mean, the result of quantum mechanics just feel counterintuitive. So one thing we can definitely say that the evolution developed a sense, intuition, how the world works. Yeah, and that works macro scale, classical scale pretty fine. We can imagine that. But on the quantum scale, it doesn't necessarily that evolution is so advanced that it created all correct thing. What I mean is that maybe for classical world we see our intuition is closest to perfect. But for the quantum mechanics, more quantum scale, that for that thing, our evolution hasn't yet developed the correct way of imagining or correct way of thinking them. For example, you can think four dimension. I mean, you just simply can't. So same way, maybe our evolution, the evolution for example, if you think that it's a bit, yes, it's a good point that, for example, for our survival, it's not necessary to know the particle quantum scale behavior at all. More than that, you need to know the whether how where does the apple falling to catch it. You need to feel that. You need to know how fast the tiger is moving towards you so that you can run. So you just got an idea. You just need to differentiate whether it's fast enough or whether it's good enough. You don't even need to measure that by quantitative scale like we do precision. For example, a car is moving 90 kilometers per hour. You don't need to do that consciously. You just need to know whether it's fast enough. If it's fast enough, then I have to run. So you developed a feeling, a quantitative thing, not a I mean, a qualitative thing, not a quantitative. Well, I mean, it's not a precise that you know that the tiger is moving that and that 90 kilometer. You just need to know it's going fast enough. It's fast than I ever seen before. So I have to run more fast. So your behavior is shaped by what is necessary to survive. So definitely it's out of range. Quantum mechanics. If we're talking quantum mechanics, it should be totally out of range because it's nowhere near to need for survival. So that could be the reason why we didn't develop the intuition and the sense to think about quantum mechanics. But we just need to grab that witness and th think the logic reasons that lie there. So the same way the the light is a particle or a wave, I think it's the wrong question. It's not a particle, it's not a wave. It's something exotic behavior of its own, but sometimes we find pattern like a, particle and sometimes we don't find like the wave. Sometimes we find like the wave. So so it's none of it just of its character on own. But that character can create or can immerse property like particle and wave. So that's just it is. I mean, if you think about it, it's a very important thing to do that we should stop. Uh, I mean, not totally. I mean, at least we should consider that our macro, we should not totally use our macro scale intuition on the quantum scale because um, that just totally that just that one is a very macro skill thing developed by intuition and experience. So just simply we shouldn't use apply them so rigidly that the quantum particle has to whether behave like particle or the wave, it has to follow what we see in the macro scale. No, it could be its own behavior of its own. So that's just the idea of the main thing that maybe we shouldn't apply the intuition and experience so rigidly on that scale too. So that's the key idea of this video.